Okay, continuing on with inverse functions, we need to know how to find the formula for f inverse from a formula for f, if there is a formula for f that you're given. Okay, so there's a number of steps here. So first, replace f of x with y, and that's just to make it easier to manipulate. Y is easier to manipulate than f of x algebraically, and so that's the only reason we do that. Okay, so I'll make a little note of that so you have it on your notes. Then you switch the x and y, and this actually gives the inverse relation, right? You're just switching x and y. Switch the first and second coordinates of each point on the graph. So that's the reflection in the line y equals x, if you want to think of it that way. So x goes to y. I made those both red so you can tell those are actually the same numbers, x and y. X becomes a y, and the y becomes an x. Okay. 3, solve for y, the red y, the new y, which was the old x. And the reason we do that is because we like having y alone on one side of the equation when we're writing it as a function, when it's a function. And we're hoping y is a function. 4, replace y with f inverse of x. Why? Because the question usually says, find the formula for f inverse. So you need to have f inverse written in your answer, so you can't just leave it as y. So you just put f inverse of x in there. Of course, you don't have to color these. I'm just coloring them so you can follow. See, this x here is that x, and that x is actually this y. And this y is the f of x, and that y is actually this x, because you're switching the x and y's. Okay, so we do this because we're asked to find the formula for f inverse. We're not asked to find y. You can't ask to find y because there's two different y's. So this is an example of where the function notation is very, very useful, because if you have two y's and you weren't using colors, you could get really confused on which y is which.